Hello, welcome to another Creature tutorial. This tutorial is going to cover the new path bone motor of Creature. This new motor allows you to do something like what you're seeing on screen here. That is, you can actually apply path motion to a bone. So the bone or a set of bones are actually going to follow a user-defined spline path as you see on screen. Now, of course, as you well know, Creature already has path motion transfer capabilities, but this new motor is going to allow you to do much more with the spline paths that you can create in Creature, and it's going to make the path capabilities even more powerful. It makes everything much more manageable, as you'll see in a moment. So please join me in this tutorial, and we're going to go through the new path bone motor in Creature. All right, so to start off, we're going to start with something simple, a simple example, of course. And let's start with a snake. We're going to try to animate a snake with the new path bones motor, okay? And then we're going to take it to the lizard in the next example. So here I have a snake image. It's stretched out, as you see. And here is the rig. The rig is extremely simple. It is literally just a set of bones, a chain of bones, going through the entire body of the snake, as you see over here. All right. So it's a very simple rig, just as I said, a chain of bones stretching out along the length of the snake. That's all it is. All right. Very simple rig. And if we go to test mode, you can see that's how the snake deforms according to the bones. Okay, so let's start the animation process. So here we have the snake image over here, right? And before we actually do path motion, we obviously need to define the paths for Creature. Now, before I continue, I want to say that Creature already has path transfer capabilities, right? So if you watch the previous tutorials, you would click on this path transfer button, and it would actually take you to a new dialog that allows you to transfer path motion onto a bone, okay? And it will write out the values, the positional and angular values onto that bone, which is fine if you actually want to tweak the values directly. But this new path bones motor, it takes it to a next level. You can actually apply a path bone motor to a bone or a set of bones, and then have that motor drive all the bones. So essentially you deal with a lot less knots on your animation data key knots spreadsheet, and similarly in the spline animation knot view as well. So it makes everything more manageable. Plus, you can do a lot more stuff with it. You can speed up the motion curve, slow it down. You can change how the bones are laid out or spread out over the curve, and many, many things. So it's much more powerful than the original path transfer mechanism, although you might still find that useful if you want to manually transfer the keyframes over from a path. So please watch the previous tutorial on path transfer if you're interested in that method. Okay, so without further ado, let's start creating a path. So what you do is you go to the Paths tab and click Add Path. Okay, you see a new dot has appeared. That's the first node of the path. So click on Path 1 and click on Edit Path. Okay, so now what we do is we actually scrub through the frames. Okay, so if I go to frame, say 84, for example, and then I'll click on Add Point, okay, and then I scroll and just click on the screen. There, a point has been added, okay. So then we go again. Let's go to, say, some other frame, and I'll add another point, like so. And I'll keep going. Okay, you can see how this works. And let's keep going. And keep going. And finally, let's add another point here. Okay, so here's our path, but it's not very smooth. So what do we do? Well, it's super simple. We just come in and we drag tangents out. Okay, so we drag the tangents out to smooth out the curve, and that gives us a smooth path, which is precisely what we want. Let's drag these tangents out. Super simple. Okay, like this. Come here again. And let's drag out like this, maybe like this. Okay, so now we start by installing the path bone motors onto the entire snake. You can see there's a chain of bones going through the entire snake, right? So the simplest way is to click on the root bone and press Control M, and that selects all the bones on the snake. and then we say install molter, and we scroll down and find our favorite path bone molter. It says makes bones follow the user defined path. Click on that. Okay, hold on, now it's all scrunched up. Don't worry about that. Select the path bone molter and let's stretch out the snake. So what we want to do is increase the scale. So if you set the scale to say 10, there you go. You stretch out the snake, right? And let's look at how our path is. And if we play the animation, already you can see our snake is following the curve, right? So you already get that for free. That's pretty cool. Already it's following the motion. Now we can obviously stretch it out even more. So we can increase the scale to say 15, and that will stretch out our snake even more. Very easy. And you can see how powerful this is. You can actually key these values over time as well. So you can have a stretching effect and compression effect over time by keyframing the scale parameter. Now, what other things can we play with this? Well, you can change the angles. You can change the orientation of the bones. You can change the offset. So I can increase the offset of the Y offset, say by 5. And then what this means is the snake will move on top of the curve, right? And if I change the offset to say -5, it will move below the curve. And similarly for X, it will move along the curve. Okay, so that is a parameter you can definitely play with. Right, now let's go back again. Let's go back and play some more parameters. Let's set the offset back to 0. Okay, we can also change the speed. So if I set the speed to 0.5, the snake will traverse the path at half the speed of the original, right? So it's slower. Okay, and if I set the speed to 2, for example, it's going to go twice as fast, right? Okay, so again, very powerful parameters you can definitely play with. You can change the time offset, so that's how far in time it starts off from the animation. So if I say frame 50, the snake's going to start off like this. Okay, so you can change the right. The time offset is also something worth playing for. And finally, you notice that the snake actually stretches. You can see that's a bit of compression expansion going on as it stretches along the curve. Now, sometimes that's what you want, but sometimes you might want to preserve the length of the snake as it traverses the curve. So what do you do about that? Well, there is this really handy keep length attribute that you can play with. So by the default is 0, which means it's going to allow the snake to expand and contract or compress along the curve. Now, if I set this to 100, it will try to preserve the original length of the snake, but it might not follow the curve perfectly, as you see, right? It looks a bit weird. So typically what you do, but although the length is preserved, I want to emphasize. So typically what you do is you set a parameter somewhere in between, like 60, for example. So it's still, the snake still tries to follow the curve, but preserves the length. You see, it nicely almost preserves the length and allows just a tiny bit of compression and expansion. So that's typically what I would do. You can also increase it to say 80, for example, and so preserve the length even more. So play around with that if you get too much distortion and unwanted expansion or compression artifacts. What you do is you just play around with the keep length parameter. And if you do want a lot of stretching, then please go ahead and set that value to a lower value so that you have a nice compression expansion animation effect. Okay, so that's basically the path bone molter. Okay, so now let's take a look at the lizard sample. All right, so we talked about the path bone molter in the previous example from a very simple snake character. Now let's do something much more interesting. So here I have a lizard from the British Library open source collection. Okay, and it's all meshed up and ready to go. So here is the rig of the lizard. Here are the bones. You can see I have a bunch of bones coming through over here for the spine, the tail, and I have bones for the legs, right? Okay, so a typical quadruped top-down rig for a character. Now, I'm gonna go and take a look at the lizard. Now, let's look at the default idle animation. So that is the lizard that doesn't actually move the curve. How does it look like? Okay, looks kind of funny, but you'll see why we're doing this when we apply it to the path. Okay, so let's examine what's going on here. Now, the spine has FK because we're going to actually put the path bone molter on it. So there's, by default, is FK or manual animation, so nothing going on there. The head is actually rotating left and right slightly. I have a rotate cycle molter on it with end and start angles of 10 and -10 degrees. right? Just to give it a little head wobble. The arms, I've again put rotate cycle motors on them, okay, to drive the base motion. Again, small angles, let's say -30 to 15 degrees. And then the base, I have the bend physics motors on the tips of the hands, so they sort of flop around in a funny way. I have the same kind of trick applied at the hind limbs. So again, a rotate cycle motor for the base of the two hind limbs. You can see over here, right? Rotate cycle. And then I have bend physics again at the tips of the feet, right? So they flop. All right. And again, I want to say, I keep repeating this, but this is the same trick you apply to the tail. So another rotate cycle motor at the base to drive it, and bend physics, an entire chain of bend physics at the tail. All right. So that concludes the idle animation, which isn't that interesting, but that's the core, the base of this lizard swimming. We're doing a swimming animation. Now let's take a look at the actual, well, it's not really a walk, it's more like a swim, but let's take a look at the actual animation. So now if I click on this, you can notice, the spine actually has path bone motors all applied to it, right? It's a single path bone motor that is affecting these chain of bones. Okay, so here's our path, right? And if I play it, that's what you get. So you get a lizard following the spline curve very, very nicely, right? And it behaves in a way that we expect, actually. And that's pretty cool. Now, what have I done to the bones themselves? Well, basically, the keep length parameter is set to 75 because I do want a bit of expansion and compression. That's kind of cool. It gives it a very nice organic creature, character feel to it. It makes it come alive. So I do want a bit of stretching. So what I've done is I've made the lizard's keep length path bone motor attribute to be 75. So there's some subtle compression or expansion, stretching things going on with the body, right? And you notice everything just comes into place because we have a full-blown procedural and physics system, which means the tail and the legs and everything just goes naturally with the bendy movement of the body, which follows the arc. And this is a very nice, fast, and pretty cool looking example demonstrating the power of the path bone motor and also using it in conjunction with the other motors like the rotate cycle motors and the bend physics motor. All right, so that basically concludes this tutorial. I hope you have fun with the path bone motor. It should be very, very useful whenever you want to achieve any kind of path motion like this example or something else. All right, so have fun animating. Thanks for watching.